We are now proceeding to show the integration of emission calculation models. We are going to show some advanced concepts with Martina Castori. Martina, you have the presenter role. Thank you.
Hello, I'm Martina Castori from Amicia. Can you please confirm that you are able to hear me and also see my screen?
Yes, we can see and hear you.
Okay, thank you. So, this is a presentation, a more technical presentation, even though it was a bit difficult to present the integration of the emission calculation model. So we just tried to give you some basic information and then give you more information using some examples. It is easier this way, and if you need any assistance on how to do that, you can of course contact us later on. So, as we have already said, there are many parameters that affect the emission factors. The basic parameters are the vehicle type, the engine technology, and of course the fuel. But there are also more advanced parameters, and we have to take also these parameters into account. These parameters are the road grade, the vehicle speed, some environmental data, the wind speed and the direction of the wind, the occupancy of the vehicle, mainly this refers to buses and trains, the road age, and of course the traffic of the road. So what we did, we tried to homogenize all these emission factors in order to formulate a common methodology and to calculate emissions from all the transport modes. The transport modes that we used in our project are buses, coaches, trains, metro, and tram. And we used all the above mentioned factors, we homogenized them, and we created a consistent methodology which applies to all these transport modes. So we created a number of tables in order to correlate these emission factors. For example, here we can see some indicative screenshots of these tables. And as you can see, there is a table with the occupancy ratio. So if, for example, the bus has an occupancy ratio between 0 and 25 passengers, this corresponds to the occupancy class 1. We have additional tables for the temperature and the humidity, which is the second table on the left, as you see it on my screen. We have some similar tables for the road gradient, for example, if we go uphill or downhill, also for the speed, and for all the other parameters that I have already mentioned. So let's see an example of these parameters. If we have a table with listing all these parameters, for example, the vehicle ID, the speed class, we have to translate these parameters to what they mean. For example, if we are referring to the vehicle ID 5, this corresponds to the urban buses, less than 15 tons. If we refer to the speed class 6, this is the speed class between 25 and 30 kilometers per hour. The emission type refers to the pollutant. For example, the emission type 2 is pollutant NOx. Road gradient 4 means that the road has a gradient between -1 and 1. And the occupancy class 1 corresponds to the occupancy class between 0 and 25 passengers. So combining all these parameters, we result to an emission factor of 0.89 grams per kilometer. So how do we combine all this information that we have? It is easier to show you this information using a case study, because otherwise it's just numbers that don't mean anything to anyone. So we took a route to start from the National Technical University of Athens and to go to the Demokritos University of Thrace in Komotini. The main trip was selected to be conducted using a coach, and intra-city travel was conducted either by metro, if it was available, or using a bus. So you can see here, this trip is fragmented in various segments. Some of them are on foot, some of them are on bus, metro. The basic here is by coach, as already mentioned, then again on foot, and then on bus. Now we will focus only in one segment of the trip, the one that is highlighted here, as you can see. And so for this segment, we have some parameters: the starting time, the trip duration, the speed, the distance, the temperature, the road type, the gradient, and the traffic. And so how all these parameters translate to something that is useful for us and that corresponds to an emission factor that we want to calculate. We see here that the emissions are calculated using an emission factor, the activity, which in our case is the distance traveled, and then there are a number of factors affecting all the emissions. So we have the road dates, which now at our case it's 10. And you can see which emission factor corresponds to which parameter in our case. The only parameter that is now not available is the wind velocity, which will be added when this information becomes available. So when I want to say something else here. So when combining all these parameters that we have for each segment, using also the tables that I have already mentioned before, we can result in the corresponding emission factors, and by multiplying all these emission factors with the activity, we can take the results that we want for the emissions for each pollutant that we want to evaluate. But the problem is that we want to evaluate the different modes of transport. So, for example, the occupancy of a bus is much less than the occupancy of a train. So how can we evaluate these results that we get? We have to calculate specific indicators which are expressed in grams per passenger kilometers. As we already know, emissions are expressed in grams. So now, for each transport mode, we calculate these indicators based on the occupancy ratio, and the occupancy ratio is the passengers that are traveling with each mode of transport. So, if we go back to our case study, we see here that for the different trip segments, different values exist for each variable. Thus, the emission factors are tailored to each trip segment. So, if we calculate the emission and the emissions first, and then the indicator, which is, as we already said, in grams per passenger kilometers, and then we add these indicators for each pollutant, so we iterate this whole procedure for each pollutant, we then can come to the result of the total emissions expressed in grams per passenger kilometers for this whole route. We also can calculate, apart from the pollutants that you can see here, the fuel consumption, the total distance, the cost, and the total time. Concerning the cost, this information is retrieved mainly from the web pages of the transport operators. In cases that we don't know the cost, we will specifically mention here that, okay, we didn't know the cost. In this example, we knew the cost, so we could also calculate the whole cost, and of course the total time. And the final step is to compare the results that we got from the bus with a petrol and a diesel vehicle. In the same manner, we tried to think that the vehicle was not only one person was traveling with a vehicle. Thus, we estimated an occupancy of 1.2. It is a value which is widely used concerning the occupancy of vehicles. So as you can see here, for this specific segment of the route, the bus emits approximately 100 grams per passenger kilometer, whereas the vehicles, whether it is a petrol vehicle or a diesel vehicle, emit much more than that. And the reason is that the bus transfers more people than a private vehicle. So that's why it's better to use the public means of transport instead of our private vehicles. That's all for this part, because as I already said, it's very difficult to give you more complex information because the basic methodology behind this step is to formulate these kind of tables that you see here, and then using these tables and the equations, you can, which is a basic equation of a multiply, you can get the results that you want. I don't know if you have any questions on this presentation.
Martina, if I'm not mistaken, for anyone wishing to have the more complex information you describe, they can find it on the deliverables menu of the website.
Exactly, exactly. The deliverable is very detailed, finding all the information behind the creation of these tables. But after that, the methodology is quite simple. It's just finding the correct parameters that affect your route and then linking them to the correct values that were already developed using these tables and just multiplying all these results. But if you wish for more detailed information, of course, you can find the corresponding deliverable.
Thank you very much.
Thank you.